Alright, folks, today we're going to talk about something that's a little out of this world: time travel. Now, before you start imagining flying cars and flux capacitors, let me clarify, I'm talking about real time travel. Did you know that? Time travel is actually possible? Not in the way Hollywood portrays it, but in a very real, scientific sense. Let me explain how. So, the idea of time travel comes straight from Einstein's theory of relativity. According to this theory, time isn't as fixed and rigid as we tend to think. It's actually more like a flexible fabric that can stretch and bend depending on factors like gravity and speed. The faster you move, the more time slows down for you. This is called time dilation. And if you were to move at the speed of light, time would actually stop completely. But we don't have to travel at the speed of light to experience time travel. In fact, time dilation happens all around us, and astronauts are actually time travelers, sort of. Here's how: astronauts in space stations orbiting the Earth are moving at extremely high speeds, about 28,000 kilometers per hour. Because of this, time passes just a tiny bit more slowly for them than it does for us on Earth. In other words, they are experiencing time travel into the future, albeit by just a few milliseconds. Over long periods, though, these tiny differences add up. One of the most famous examples of this is the twin paradox. Imagine you have two twins. One stays on Earth, and the other boards a spaceship that travels close to the speed of light. When the space-traveling twin returns home, they will have aged more slowly than their sibling on Earth. So, while it may seem far-fetched, time travel into the future is not just science fiction, it's built into the fabric of reality itself. Now, if you think that's cool, wait until you hear about black holes. Black holes are some of the most extreme objects in the universe, and they warp time and space around them in ways that defy our everyday understanding of physics. According to Einstein's equations, the closer you get to a black hole, the slower time moves for you. If you could hover just outside the event horizon, the point of no return, it's possible that entire centuries could pass for the rest of the universe, while only a few moments go by for you. Essentially, black holes could be nature's ultimate time machines. But we don't have to rely on theoretical physics to see time travel in action. Let's talk about something a bit closer to home: GPS satellites. You know, those things in the sky that make sure you never get lost? GPS satellites are actually a real-world example of time dilation. Because these satellites are moving fast in orbit and are farther from Earth's gravitational pull, time ticks faster for them than it does on the ground. The engineers who designed the GPS system had to factor in these relativistic effects when calculating positions. Otherwise, GPS would be inaccurate by several kilometers. So, next time you use your phone to find directions, just remember, time travel is what's keeping you on the right path. So, if traveling into the future is theoretically possible, what about traveling into the past? This is where things get tricky. Einstein's equations don't explicitly rule out time travel to the past, but most physicists think it's far more complicated, mainly because it would create paradoxes. You know, like the classic grandfather paradox. If you traveled back in time and stopped your grandparents from meeting, how could you exist to go back in the first place? These kinds of paradoxes suggest that backward time travel might be impossible, or at least not as straightforward as forward time travel. That said, some physicists have proposed theoretical structures called wormholes as a possible solution. Wormholes are essentially shortcuts through spacetime that could connect two distant points, and, in theory, they could allow someone to travel from one point in time to another. However, we haven't discovered any real wormholes yet, and even if we did, keeping them stable long enough for time travel would be a monumental challenge. Another fascinating idea comes from the realm of quantum mechanics, the branch of physics that deals with the very smallest particles in the universe. In quantum physics, particles don't behave in ways that align with our everyday experience. They can be in two places at once, communicate instantaneously over vast distances, and even travel backward in time, at least mathematically. Some scientists are exploring whether these strange quantum effects could be harnessed for macroscopic time travel. We're still a long way from making that happen, but the possibilities are tantalizing. Now, some of you might be wondering, What's the point of all this? Why should we care about time travel if it's just theoretical or happens on such a small scale? Well, understanding the nature of time doesn't just open up possibilities for cool sci-fi stories. It's also crucial for advancing our technology and deepening our understanding of the universe. Take, for instance, the concept of time crystals. This is a recent and groundbreaking discovery in physics. Unlike normal crystals, which have a repeating structure in space, time crystals have a repeating structure in time. They oscillate back and forth forever without ever losing energy. While this sounds mind-bending, it could have huge implications for the future of quantum computing and other advanced technologies. And of course, there's the philosophical side of it. Time is something we all experience, but it's also one of the biggest mysteries of the universe. What is time, really? Is it a constant flow from past to future? Or is it something more fluid and flexible? When we dig into these questions, we're not just learning about physics, we're also exploring what it means to exist. So, the next time someone says time travel is impossible, you can smile and tell them, actually, we're all traveling through time, right now. And who knows? Maybe in the future, we'll find ways to bend and manipulate time in ways we can't even imagine yet. After all, we've already taken the first steps with astronauts, black holes, and GPS satellites. Alright, that's it for today's deep dive into the mind-bending world of time travel. If you found this fascinating, and how could you not? Make sure to hit that like button, subscribe, and drop a comment below. What would you do if time travel were possible? Thanks for watching, and until next time, keep your curiosity alive. Next one coming soon.